There should be two videos for this, so this will be the first one for operations with radical expressions. And by operations, they're just talking addition, subtraction, multiplication, and division. But these first problems are just addition and subtraction. And I'm going to make this larger. If you remember, having 5x and 3x, the whole reason you can combine those is because the x's match up, and those are like terms. So I can put 5 and 3 together, and it becomes 8x. Now, even though this might look a little bit more different, I'm going to erase these x's and instead swap it out with something with a radical. But not just a radical, but the same radical. So there's the square root of 2. So if I have 5 square roots of 2 and 3 square roots of 2, that just means you're going to have 8 square root of 2. And I'm talking about that quickly because I think it's kind of a clear concept. So I'm going to rewrite problem 1, 4 times the square root of 3 plus 6 square root of 3 minus 5 square root of 3. Notice that I'm not bothering saying times every time. And when I look at this, these are all square roots of 3. And I guess I'll do this in 2 steps, even though you'd probably be okay saying 4 and 6 is 10 minus 5 is 5. So first I'll just combine 4 and 6 to get 10 times the square root of 3, because those both match up. And then I'll rewrite minus 5 square root of 3, so that both the top and bottom lines now match. And when I move on, 10 minus 5 gives me 5, and I have 5 square root of 3. Now the same deal as before. If you were taking a test, you could punch the original problem into the calculator, get some sort of decimal approximation, and then type the result answer you got into the calculator, get another decimal approximation, and if those two agree, you're pretty confident that you're correct. Okay, moving on to problem 2. 12 square root of 5 plus 3 square root of 7 plus 6 square root of 7 minus 8 square root of 5. Now, earlier, we might have rewritten this problem showing the square root of 5 parts first, and then the square root of 7 parts next. But I think that this problem's not crazy difficult, so I'm just scanning from the left to the right, and I see something with the square root of 5, and I see something else with the square root of 5. And those numbers out front are 12 and 8, and 12 minus 8 gives me 4 square root of 5. And then moving on to those middle terms that showed up in this problem, 3 and 6 combined to give me 9 square root of 7. The only thing I'll point out with regards to neatness, notice that my radical here is not extended too far. It's not over my plus sign. Things are pretty clear. As far as rewriting this in a different order, like having a smaller radical first and then a larger radical second, that doesn't really matter too much. I think that 3 and 4 can be OYO problems, so I'm just going to write this in red because I'm not even going to bother showing the work rewritten, but I do want you to rewrite and do these on your own so that you can check them with what I have in just a few seconds. 3, 2, 1. If you have written this out and had any problem with problem 3, maybe it would help to put a 1 in front of that radical 2. It's just the same as saying 2x plus x and having to know that that's the same as 1x. The only other thing I guess I could add for the second problem is you're dealing with integers, so negative 14 plus 6, there's a chance to mix up the signs and make a small mistake there. But like I said, I think these are kind of a little bit cut and dry. Now that whole order doesn't matter thing, often you would probably avoid having a negative out front, meaning you might more commonly see the way I first wrote it as opposed to the second way. But it doesn't matter. And this is in red only because your work has to be shown, and I am not telling you to not write that down because it's in red. Expressions with unlike radicals. These get a little bit more complicated because at the start of this problem where we're told to simplify, we have 2 times the square root of 20